So, today's puzzle is gonna teach us something about graphs. So here it is. We have a grid of triangles, and we have to write the numbers 1 to 16 into the triangles, but consecutive numbers must be written into adjacent triangles, that is, into triangles that share a side. And rotations and reflections don't count. How many can you find? So keep watching if you want to see the solution. And I'm going actually to give you two solutions. One direct solution, so to speak, and one solution that uses graphs to show you better what's behind the puzzle. So let's get started. Here's the grid, and first of all I have to think, where can I put the number 1? And I can put it right here, or I can put it there. And there are no other possible positions for number 1 because all the other positions are just the same with a reflection or with a rotation. So in the first grid, where can I put number 2? I can put it here, or I can put it there. So I have two possible starts, and I have to keep track in mind of all the possibilities. And in the second grid, I can put number 2 there, or I can put number 2 there. And I'm starting to lose track of what I'm doing, but I'm gonna try to go on anyway. So in the first grid, where can I put number 3? I can put it there. And now number 4, I can put it right here or right there. And things are getting complicated, so let's continue with grid number 1. Let's see if we can get at least one solution. So number 5 is mandatory, and number 6 goes there, and etc. We can go on and we find one solution. And so now we should check all the other grids and all the other variations, but we won't do that because that's boring. We're gonna try to solve the puzzle using graphs. And we're gonna use what is called the dual graph of a map. So we have our map, or our grid of triangles, and we're gonna create a graph. Remember that a graph is a connection between dots. We have some dots and some edges that connect the dots. So we're gonna put a dot in the middle of each triangle, and we're gonna connect the dots that correspond to adjacent triangles, like this. So this graph corresponds to the previous map. And in this graph, the solution is much easier. Because, look, I have to find a path that visits every dot just once. And the problem became a visual problem, so it is much easier because, for example, I can start in the corner and go clockwise all around, or I can start in the corner and go all around counterclockwise, or I can start counterclockwise but then go clockwise. And of course, I still have to find the solutions and look for them, but it is much easier because the numbers are not there and it is just a visual problem. And the solutions are actually 6. Did you find them all?